Okay, so good day to our grade 8 Makati Science High School students. For today, we are going to continue our lesson on circles. This is going to be our part of our first topic for the fourth quarter. So this is on introduction of circles, and we're trying to solve problems have that are a bit challenging. Okay, so not too challenging, but are a bit challenging, just the right challenge. So let's try this first problem. Okay, so the first problem we have in the diagram below, OABC is a rectangle, the arc OXBY is drawn with radius OX and center O. If OC is equal to 3/5 of OY and AX is equal to 2, so what is the length of OB? Now, on our given diagram, our given model, we know that OX, OB, and OY are radii of the circle. They're all radii of the circle. So how do we prove that? Okay, so since this is a quarter circle, so that will mean that these sides here, OX and OY, are radii of a circle. And since OB is it's the diagonal of our rectangle, it also connects with one point to the circumference of the circle coming from the center of the circle on the other end. So that's why it's also a radius of the circle. So therefore we can say that OX is equal to OB is equal to OY. Now, what other observations can we write? So since we know that OX, OB, and OY are radii of a circle, all of them can be denoted as R. Now, since we know that AX is equal to 2, and we know that OX is equal to OA plus AX, therefore we can denote here that OA, this line segment here from point A to O, is the radius, it's the entire radius subtracted by 2. Okay? Because again, how do we know that? So OX again is the radius, and OA is a part of the radius. This is the one that we're trying to solve, and AX is 2. So if this is positive 2 and you transfer positive 2 to the other side using transposition, therefore OA is equal to R minus 2. We have another clue. So OC is equal to 3/5 of OY. Now we know OY is also a radius of the circle, and OC is missing. To find OC, since we know, or we're given that OY is a radius of a circle, therefore OC must be 3/5 of OY. And what shape? What shape is inscribed in this quarter circle? So there is a rectangle. There's a rectangle inscribed in the quarter circle. So if that's a rectangle, most likely it would have right angles. And if it has right angles, therefore what theorem, the most used theorem that we use in geometry that we can use, so we can use the Pythagorean theorem. We use the Pythagorean theorem, sometimes called Gauss theorem, to solve for the value of the radius. And what's the formula for the Pythagorean theorem? So that's a squared plus b squared is equal to c squared. Since we want to know the value of OB, OB is the diagonal of the rectangle, and we know that OB is also the radius of the circle. Therefore, we can now solve for the value of the diagonal through the radius of the circle that we're given here. Since we know that OA is a part of that rectangle, okay, and we know that OA also forms a right triangle here, okay, we can square it plus the square of AB. And since we know that AB is parallel to OC and is congruent to OC, therefore whatever the value of OC is, which is 3/5 of OY, that's also going to be the value of AB. And that's equal to c squared. And we know that c squared is just OB squared. And we know that OB is the radius of the circle. Okay, so let's try to write that down here on our formula. So OA is R minus 2 squared plus AB, which is 3/5 of OY squared, is equal to OB squared, which is the radius again of the circle. Okay, so that's going to be R squared. So it's r minus 2 squared. What's quantity r minus 2 squared? So that's r minus 2 times r minus 2. So that should give us r squared minus 4r plus 4 is equal to, so what's 3/5 squared? So that's just, I'm sorry, plus 9 over 25 r squared. Okay, since we know that OY is r, OC is equal to 3/5 of r. Okay, so that's 3/5 of r, 3/5 of r squared, which is 9 over 25 r squared. Okay, that's gonna be equal to r squared. Okay, and since we have both r squareds on the left side and the right side of our equation, so we can cancel the r squareds here, and therefore we are left with, if we're going to try to rearrange it, so that's 9 over 25 r squared minus 4r plus 4 is equal to 0. Now, we don't want a 25 here on a denominator, so we have to multiply both sides by 25. And therefore, the 25 cancels out, and this should give us 9r squared. And what's 25 times 4, so that should give us negative 100r plus 100 is equal to 0. Now, what equation do we have here? It's raised to the power of 2. So this is the most common equation that you will see in your 9th grade. So that's the quadratic equation. So that's a 9r squared quadratic equation minus 100r plus 100 is equal to 0. Now, there are many ways to solve quadratic equations. You can use calculators factoring in the quadratic equation. Okay, so if we're going to use the quadratic equation or the quadratic formula, so that's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's write our numerical coefficients. So a is equal to 9, b is equal to negative 100, and c is equal to positive 100. So therefore x is going to be equal to negative times negative 100 plus or minus the square root of negative 100 squared minus 4 times 9 times 100 all over 2 times 9. And therefore x should be equal to positive 100 plus or minus, so what's 100 squared? I think that's 10,000, but let's just check. So that's 10,000 minus 4 times 9 times 100, so that's 3,600 all over 18. Okay, so therefore x is equal to 100 plus or minus the square root of, so what's 10,000 minus 3,600, so that's 6,400 all over 18, and that should give us around 100 plus or minus 80 all over 18. Okay, so what's 100 plus 80? So that should give us 180, okay, divided by 18. And then what's 100 minus 80 divided by 18? So that's around 20 all over 18. So 180 divided by 18, so that's positive 10. And 20 divided by 18, I think that's 1 point something. 1.11. Okay, so which of these two values is the value of x? Now, both of them are positive, so that means both of them have like good chances of being the value of x. But since we know that ax is equal to 2, and we know that AO is higher, it's greater than AX. Okay, so therefore, since we know that this is 2, most likely the value of AO here should be greater than 2 as well. Okay, so therefore the value of OB here, since we know that x is equal to 10 after having solved it using the quadratic equation, therefore OB is equal to 10 units. And that's how we solve this problem.